One really important application of correlation analysis is to produce reliability and validity evidence for the instruments that we use to assess psychological traits in the field of psychological research. Um, so I think we mentioned in earlier lecture, and then we'll get into this more in the next class, that some variables are measured indirectly and called these latent constructs or latent variables. And latent variables can only be measured by observing their indicators. Indicators are observed variables that let us know that a particular latent variable is present. Latent variables are theorized to exist. Um, for example, happiness. We sort of have this concept of what happiness is, and we kind of have a theory of what that construct looks like. And then we see certain indicators of that. Somebody smiles, they laugh, they engage in an activity. We sort of infer that they must be happy. They're doing these things. Another example, ADHD. You can't measure ADHD directly. There's no formal technical way to directly measure that. It's a theoretical construct. It's a constellation of behaviors that have been operationalized by psychologists. And so when we assess for ADHD, we look at indicators. So they can't sit still, not completing tasks, and so forth. Then we infer that ADHD, or whatever it is we call ADHD, is present. So psychologists frequently are developing instruments for assessing indicators of latent constructs. An issue we run into right away is how much faith or how much confidence we can have in these instruments. And there's a whole science that goes into developing instruments, so we won't be able to get into all of that. But we can focus in on two simple ideas: reliability and validity. And a lot of times correlation, now there's other approaches as well, but a lot of times a simple correlation analysis can be used to help build evidence for this, that we can have some faith that we're measuring some trait consistently, and we're actually measuring what we think we are measuring. Um, Reliable measures, when we talk about reliability, reliable measures provide consistent measurement from occasion to occasion. All right, so that's really what that means. We're going to get the same result every time we use it. So if we use the Wechsler's Abbreviated Scales of Intelligence, the WASI, we'd use this to quickly estimate the IQ of an individual. So of any age, I think it goes down to maybe age 5 or 6 and up to as old as you want to go. So if we have a kid in third grade, Billy, and we estimate he has an IQ of 120, so it's well above average, a little over. The standard deviation is 15, mean is 100, so a little over standard deviation above the mean. If this test is reliable, he should also score above average in fourth grade. So we're assuming his IQ, with all of these, with reliability analysis, we're assuming the actual construct hasn't changed. His IQ hasn't actually changed dramatically from third grade to fourth grade. And there's a whole controversy about that, but assuming it hasn't, we should get roughly the same score. If we test him in fourth grade and now we get a score of 80, like well below average, we wonder what's going on with the instrument. According to classical test theory, we have an observed score. So let's say it's an IQ test, and let's say we get 120. Well, that is comprised of a true score plus some measurement error. So the true score, this is theoretical. This is hypothetical theoretical value. This is Billy's true IQ. Let's say it's 117. And then the rest of it is a measurement error. So in this case, 3 points would be measurement error, and the rest of it is this true, theorized true score. So the instruments we use in psychology are not going to be able to measure someone's true score exactly. There's always going to be some kind of measurement error. And that means, maybe his true score is 117 and we happen to get a 120. Next time we get 115, let's say, or 113. There's some level of measurement error. Maybe Billy is especially distracted one day and it comes out being 110. And now there's a lot of measurement error there, 2/3 of a standard deviation. So we want to have an instrument where we have as little measurement error as possible. So the more reliable, the less measurement error. The less reliable, the more measurement error. Another example, let's say we're interested in assessing a child's problem behaviors. So this kid is getting in trouble at school and at home, just out of control. And the therapist, let's say he's working with a therapist, the therapist is trying to get a baseline and trying to identify what the issues are, when and where they take place, how severe they are. Maybe the therapist is trying to make a diagnosis, and this is going to give him, provide the therapist information for that. And so the therapist gives both parents a checklist to fill out. And so it has a list of behaviors, and they, indicate, does this occur, how frequently, how much of a problem is it. And let's just say, for the sake of our example, that there's this defiance construct, and it comes in a score of 1 to 10. So I'm just making that up. So let's say on the mother's survey, the level of defiance is a 9. All right, so the mother's saying this kid is very defiant. But the father's survey puts the defiance level at 7. Right? So now we have to ask ourselves, well, what's the true score? What's the true level of defiance? The discrepancy between these evaluations is a reflection of measurement error. If both of the surveys rated the level of defiance at a 9, this would suggest that the instrument is very reliable. So whether mom or dad, maybe teacher or youth leader, who knows, whoever is doing the rating, it comes out to 9, we have a lot, oh wow, this is a good instrument. Everyone's coming up with the same score. What about the other way? What if mom rated it, used this instrument, when mom did it, came out to a 10, but dad's came out to a 2? This is an extreme difference. This would be a very unreliable instrument. This means that a lot of measurement errors muddling the results. And so if you get that, you don't have any idea what the kid's real behavior is. It's not reliable. There's different kinds of reliability. And so here's 4 common approaches: test retest, parallel form, inter-rater reliability, and internal consistency reliability. Now, correlation analysis is at least sometimes used to calculate each of these types of reliability. There's much more sophisticated approaches, but a simple correlation that you'll know how to do by the end of this week, and we'll give, I believe in the lab, you'll be able to see some real life examples of that, can be used to start building reliability evidence. Test, retest. Well, it's kind of like it sounds. You test and you retest them later, and you're looking to see that this score is, there's stability within the responses, that there's consistency. This, of course, is assuming that the trait is stable, right? So it may be a personality. You wouldn't expect someone's personality to change very dramatically over, say, a month or 6 weeks. And so a personality test should give the same results in January as it does in, say, March, unless the person experiences some trauma or some intense therapy and actually their personality is metamorphizing. Otherwise, it should just basically stay the same. IQ test, same kind of idea. It should be roughly the same over time. A measure of chronic depression. Remember, so chronic depression means it's pervasive. This shouldn't radically change from week to week. Right? So somebody might have issues with depression, and 1 week they feel a little better, 1 week they feel worse, but that shouldn't be reflected in the score. Right? They should have the questions written in such a way that even if I'm feeling a little better today, it can still reflect the fact that I'm depressed, and even if I'm feeling especially bad today, it should again reflect that sort of that general condition. To do this, to test it out, basically you have some participants, some volunteers, and you give the test to them, and then you wait later, maybe a few weeks, and then you test them again, and you simply find the correlation between the two administrations. You just correlate them. So if you have some score, let's say it's a bunch of kids in that behavior measure, and you have, mom and dad, or this would be test retest, so it'll be over time. So if you have the kids rated in March and the kids rated in April, and you don't think the behavior has changed since then, maybe there's been no therapeutic approaches happen, you would expect the scores to correlate from one time to the next. Usually they wait a few weeks before testing them again. And this is where it gets difficult to decide how long to wait. If you do it right away, the person's just going to remember their answers, and they will put the same thing just because they remember what they put last time. If you waited 5 minutes or maybe a couple days, depending on the test, the person might learn how to do it. So an intelligence test, there might be little blocks, there are little patterns they manipulate, and they're looking at nonverbal intelligence or nonverbal cognitive processing. And if you keep doing it, you're going to memorize it, and you'll get faster and faster just because of practice. It's called a practice effect. And so it'll make it seem like your test isn't reliable, but really, the scores are going up because they're getting used to the test. Conversely, they might get tired of the test. Maybe it's a long test, and so the next time, this test is so long, and they just space out halfway through. And so it makes it seem like the test is unreliable, when in fact they just got fatigued. It's called a fatigue effect. On the other hand, you don't want to wait so long that the characteristic under study changes. So if maybe it's a behavioral problem, and the kid's in therapy, and you measure them at one occasion and wait 6 months, well, their behavior should have changed over that time. They're like a math test. If you measure them at the beginning of the school year, hopefully they're learning math at school. By the end of the year, their score should go up. So you don't want to get confused and think, wow, this test is reliable. The score's changed. When the issue is that the people changed, the trait changed. Okay, inter-rater reliability. So we talked about test, retest, inter-rater reliability. Okay, so some instruments have to be you have somebody rating behavior. So somebody observes something and then they write down a score, and that's how the score is produced. So in the military, for example, when recruits are being trained to do different things, firing a mortar or cleaning a gun or whatever it is they need to do, they want to make sure they've really learned the skill. And if it's firing a mortar, it's not a paper and pencil test. There might be a paper and pencil test related to that, but you have to see them fire the mortar and see if they blow up the thing they're trying to blow up. So a drill sergeant might be rating that using some kind of a rubric or criteria. Principal, there's a new teacher, and the principal wants to see if they're doing a good job. Can they manage the classroom, for example? So they have to sit down in the classroom and watch and fill out some kind of a rubric or there's some kind of criteria there. In school, professor reads your essay. So you write an essay, professor reads it. There's some kind of a rubric or criteria, and they produce a score. If the instrument, in this case it might be some sort of a rubric, if it's reliable, you're going to get the same score no matter who is observing the behavior, assuming the raters have been properly trained. So if you have 3 different drill sergeants rating the cadets or whatever, then it shouldn't matter who's doing the rating. You know, say, oh, well, I hope so-and-so does the rating because they grade easy, or so-and-so grades hard. It should be consistent. That's inter-rater reliability. So the way you would find that out, one way, is you just have 2 people do the rating. It's blind. They don't know what each other is writing down, and then you just find the correlation. I worked on a grant at the beginning of, I want to say, really about the middle of my PhD program. I was working on a grant, and we were doing testing with some kids, and we would have inter-rater reliability built. So if there's somebody who didn't have any kid to test for whatever reason, they might sit down next to the other tester and they'd score all the tests on their own, but they would hide their answers. And at the very end, they would take a look at these and see what the correlation was. And if it was high, we felt good about how well we were trained and that the results were reliable. And if they were different, then we knew we had to be retrained. Okay, parallel form reliability. All right. So we had test, retest, inter-rater, parallel. Not sure why these are in a different order. I'll change that at some point. Sometimes you have to have more than one version of a test. Usually it's because if you use the test over too quickly, then the person just remembers the scores or it affects it. A vocabulary test, if you keep taking the same vocabulary test, eventually you're going to remember the words that are on it, and then when you see those words out in the real world, it'll draw your attention to them. You're more likely to learn those words, and then now when you take the test again, it's going to make it seem like your overall vocabulary has improved when really you've just learned 3 or 4 words. So the theory of a vocabulary test, so this is a random sample of all the words that you could know. It's not supposed to be tested on these particular words. It's supposed to be this idea of your global overall vocabulary. Right? So the assumptions of the test are conditioned on the idea that you haven't been trying to go out and learn these exact words. That's why teaching to the test is a problem. And you hear about standardized testing in schools, and they always say you should not teach to the test. And what some schools and teachers will try to do is figure out exactly what's on it, teach just that, and then it gives us the sense that the kid's global ability is higher than it really is. So anyway, that's why you need to create parallel forms. So it's measuring the same thing, but with basically just different questions. It's important to know, though, that the person's going to get the same grade no matter which version you're using. So basically, you give people both versions and find the correlation. So Johnny takes version A, Johnny takes version B. Susie takes version A, Susie takes version B. Again, you're doing this process to validate, or to not validate, but to find reliability evidence for the test. This isn't when you're using it in quote-unquote real life. You're the test developer. Right? So you give people both versions when you wouldn't normally do that, and then look to see how well they're